It seems like a good time to start. So, one of my colleagues in the SUSE Linux Enterprise lab in Beijing, Jiadu Zhang, unfortunately couldn't make it here, so I'm presenting this talk on his behalf about extending pacemaker to support geographically distributed clustering. So, at Linux Plumbers Conference in 2010, don't heckle you, various HA people had lots of interesting discussions about things that needed to be done with pacemaker, and one of them was support for geographically distributed clustering. Pacemaker running on CoreSync really likes to run on something that looks like a local area network. So, is this on, is it? So you can run your cluster in your data center, or you can stretch it out a bit to what we call metropolitan area clusters, where you've got some sites that are maybe a couple of tens of kilometers from each other, but you still want to have redundant links, and your latency still needs to look more or less like a local area network. So this isn't going to work for east to west coast of a continent. You might not have redundant links, and you certainly don't have sensible latency. So the basic idea is that each of your remote sites runs its own pacemaker cluster, and we're kind of doing a cluster of clusters concept on top of that. So if one site goes completely down, the resources running at that site can then be failed over to the other site. This is only a mechanism for knowing that a site seems to be up and for managing resource failover between two or more sites. It doesn't cover replication of configuration or replicated data. That's somebody else's problem. So the idea here is that to pacemaker, we've added what's called a ticket, which you might think of as a cluster-wide attribute. Ticket support in pacemaker, part of it might have been there in 1.1.5, but it's definitely there in version 1.1.6. And you can configure resources to depend on the existence of a ticket. So if a given cluster doesn't have the ticket, those resources that depend on it will not be allowed to start. In principle, this means that you could actually set up a couple of independent clusters, and you could manually grant and revoke tickets on those sites if you wanted to do this purely manually. That's fine, but it doesn't help if you want to automate failover, and there's nothing there in the underlying ticket system preventing you, the administrator, from accidentally assigning the same ticket to two sites, and then everything's running all over the place, and nobody really wants that. As I just suggested, we need a means of automating this and keeping track of tickets. So enter the Booth project, which is a cluster ticket manager. It's called Booth as a play on, you go to a ticket booth to get a ticket, right? The primary concerns for having some means of monitoring multiple sites are listed here. The system voting on which site gets a ticket needs to be completely determinate. Every site needs to have the same view of who owns what ticket. You can't have one site deluding itself that it owns a ticket when another site actually has it. We need to avoid split brain, and this is basically a distributed consensus problem. So the Paxos algorithm was selected here. If you're interested in this, It's a family of protocols for solving consensus in a network of unreliable processes. There's a very long Wikipedia page on it, which describes it using many more words than that, and it's got pretty little state diagrams. It's interesting. No, really. So the basic design is that every site, everywhere you've got one of your clusters running, runs an instance of the booth daemon. Within each of those individual pacemaker clusters at a site, the booth daemon runs with a virtual IP address in a resource group, so you can only have one instance of booth running at any site. If an individual node at a site goes down that's running booth just fails over to another node so the other sites can still see it. Obviously, you've got to have your firewall configured such that the IP address it's on is, accessible to the other sites, but that's okay. The other thing you can't do is, if you only have two sites, you're screwed because you can't get quorum. It will not work. So we have the concept of an arbitrator, which is some system somewhere else. It doesn't have to be a pacemaker cluster. It just needs to be capable of running a single instance of the booth daemon, and that will act as an arbitrator to help in the voting for who gets what ticket. Apparently, you supports any number of cluster sites and any number of arbitrators. I've already covered those points. And there's a booth client command that you can run on any site or on the arbitrator system to say, please grant a ticket to this site, and then those resources will come up, or please revoke a ticket. Here's a picture, which more or less shows what I said on the last slide. Two sites, booth running at each one, a third arbitrator. If you had three real clusters, you wouldn't need the arbitrator. This dotted storage line here, that's the thing that I mentioned was somebody else's problem earlier. In terms of implementation, the Paxos and Paxos lease algorithm underlies all of this. I believe Jiaoju has some interest in actually splitting off that the Paxos part into a separate library so that other people with distributed consensus problems can then use that. That hasn't happened yet. I don't know what sort of time frame there is there, but that's something that he's very interested in doing. Ticket management builds on top of the Paxos layer. Transport between sites is via UDP at the moment. When these slides were written, support for more protocols was planned. If you go and grep through the source code, you'll see some functions that are suspiciously named TCP and SCTP, so there's something going on there, but for now, UDP. And there's some other bits and pieces in there. There's a configuration file parser. There's a timer. Tickets, once they're granted to a site, are periodically renewed. The timeout for a ticket defaults to 600 seconds or 10 minutes. If a ticket is unable to be renewed within that time period, it will get revoked from that site. That expiry is configurable on a per ticket basis if you want to change it. So that's about the overview. In terms of how you actually configure this stuff, I should have done Florian's show of hands before. Who's familiar with pacemaker? That's enough that you can tell you, and you can tell you. No. Each of your sites is an independent cluster. You're going to have to configure pacemaker at each site, configure each of the resources at each site. And then what we've got here, this resource ticket, may look suspiciously like a location constraint, because that's effectively what it does. The first resource ticket line here, don't worry about the ID, but it says that ticket A means that resource 1 will only be allowed to run on this cluster if that site has been granted ticket A. There's an interesting attribute you can set here, which is the loss policy. If that ticket expires or is gone for whatever reason, in this instance, the nodes running that resource will be fenced. The reason that you can do this is if you have some resources that take a very long time to shut down, you might want them to come up at another site a little bit quicker than that. So you have the option of just, if this site loses a ticket, kill the damn thing, something else can have it. If you're running master-slave resources, as you might be if you're using the Postgres thing that Mori-san was talking about, or whatever. There's the option to demote the resources when the ticket goes away rather than stopping them, and you can also have it stop the resources or freeze them, which means it does nothing with them at all. You also need to configure the booth resource. This is simply an IP address and an instance of the booth daemon in a group, and that will run at each site. Booth itself has a configuration file. You need to have the same file on all of the nodes at all of the sites. Csync2 is useful for this within a site, may or may not be across sites depending on what you're doing. This says what it says on the screen. Protocols ports. You need one entry for every arbitrator and one entry for every site to tell it the IP address. You need one line for each ticket that it's managing. If you wanted to specify a different expiry time for the ticket, there's some more syntax here. You can put a semicolon and the number of seconds to expire the ticket after.
If you had just if you had no arbitrator but 3 separate sites, would that you just specify those? If you
there's a thingy on the. I didn't want to get too close because of feedback.
If you had 3 sites, 3 active sites,
yep.
and you did not, you would just specify 3 sites. That arbitrator line is only required if you have a site which is just an arbitrator.
That's correct. Yeah. If you only had 3 sites, there would be 3 site lines, and that's all. Okay. Something I didn't mention before, the administrator does actually have to actively grant a ticket to a site before anything will happen. So from any site or arbitrator, you can run the booth command line tool. Booth client list will list you all of the tickets and where they're at. To grant a ticket to a given site, booth client grant ticket name, site IP address. To revoke, a similar sort of thing. You can also use the underlying CRM ticket or CRM site ticket commands, but don't, please, because you'll accidentally grant a ticket to a site that Booth's already managing. So just, if you need to, you can, but you should let Booth do its thing. I'm going to try and preempt one question. If you've got more than 2 sites, 3 or 4, what will happen when one site loses a ticket is the other sites will vote about who gets that ticket and where those resources come up. So a potential question there is, can you have a preference for what other sites or resources are going to come up at? As far as I can tell, this hasn't been documented yet, but there is, if you look at the code, a notion of a weight applied to each site. So if you do actually want to, if something's running here, then you want it to try to go there before it goes there, there's something in there that'll help with that. With that, The project itself is hosted on GitHub in the Cluster Labs repo. Please go look at the code. Please build it and play with it. You will need pacemaker 116 in order to do so. The astute observer may have noticed drafts of SLES 11 SP2 HA documentation which mentions booth. I'm not sure I'm allowed to make product announcements, but given that that draft is actually publicly accessible, you can read into that what you like. Pacemaker mailing list is probably the best place to ask questions. With clusterlabs.org if you're not familiar with that. And I think that will about do. Do we have any questions?
Those commands about the tickets looks interesting. What happens if I make a mistake and suddenly 2 nodes or 2 sites or 3 nodes and 3 sites at the same time think that they own the ticket? The same ticket.
The same ticket. Okay. Sorry, slightly more seriously. At the pacemaker level, pacemaker's policy engine knows about tickets and it knows that resources depend on them. Individual clusters have no idea what the other clusters are doing, so booth arbitrating them. So you can, there's nothing within pacemaker stopping you from hurting yourself in that regard if you actually grant one there. If somehow you ended up in a situation where, let me start again. Unless booth is broken, it's not going to grant the same ticket to multiple sites. That would be a very, very large, horrible bug. I'm not sure if that answers the question.
What if it does anyway?
If it does anyway, if somehow it's broken and the tickets get granted to 2 sites at the same time, those resources are both going to come up on both sites. And hopefully somebody will page you. The point of this, the design and the Paxos algorithm and distributing consensus over who can get what is to make sure that that exact problem does not happen. So, yeah. Anybody else?
Thanks. This is actually probably more of a question for Florian, since he's sort of just wandered away. DRBD proxy. Can you? Do you know of anybody that's actually tried running this stuff up with DRBD proxy?
I can take that one. Not in production, no, because this part is not really officially released yet. But yes, so I guess the underlying question is, how do we solve the issue of actually getting the data across?
Yeah. But the other person's problem.
Yeah, someone else's problem. So yes, DRBD in protocol A with DRBD proxy is an option. So that's one possibility. Another thing that I can think of right now is GlusterFS is getting georeplication in 3.3. And that would be another one. In my personal humble opinion, it's not quite as mature as DRBD with DRBD proxy, because what you can do with DRBD is you can easily fail back, which in Gluster basically is a major operation. But you can still use it for DR, but not necessarily for actually following the sun. But those would be 2 options that come to mind. For database applications specifically, it would be database replication, MySQL replication, Postgres streaming replication, Galera, Tungsten, what have you.
Going back to my monkey rolling.
Jiaju is actually quite interested in the geo-replication problem. And I'm sure he's interested in hearing from people who are doing this or who are have problems that need solving. So if you're doing stuff in that area, come and grab me later and we'll have a chat. Anybody? How am I doing for time? Rob's due to start in about 2 minutes. How you doing, Rob? Okay, so if there's no further questions, I'll hand over to Rob. Thank you.
Thank you.